Let's look now at the power rule for exponents. When you talk about exponents, you talk about repeated multiplication. With that in mind, you have some properties that occur when you place exponents on other exponential expressions. So for example, let's say we had x to the third power. All right, well, that's an expression. So just like any other expression, I could square it. All right, well, what does that mean? X to the third means x times x times x. But when I square something, that means I multiply it times itself. Okay, so that's another x times another x times another x. Well, notice that's just 6x's multiplied together. The parentheses aren't really doing anything. It's all just one multiplication. Oh, so then that's x to the power of 6. Oh, but that was because we had two groups of 3. 2 times 3. Oh, that's the product of those two numbers. This is what we can refer to as the power rule for an exponent. Let's begin with a base. We'll typically call base b for base. Let b be a real number. And let's let n and m be integers. Then, if you have b raised to a power of m, and you take that and raise that to a power of n, it'll give you b to the power of m times n. So the product of those two numbers there. Okay. So as further examples of this, you could say something like x to the power of 5 raised to the power of 3. And we could write it out in full like this, but it's going to be a little bit simpler if we simply follow this. That's going to be x to the power of the product of those two numbers, 5 times 3. Or in other words, x to the power of 15. Now, this right here on its own is really all you need. However, if you analyze this a little bit more carefully using different kinds of expressions, you actually get slight variations on this. Now, it's not any different from what's written here. What I'm about to show is not different from what we have here. It's simply an application of this rule to some more specific cases. So consider something like this. Let's say I have x to the power of 3, y to the power of 4, and I'm going to raise that whole thing to the 5th power. You can tell we're very hard to come up with examples, 3, 4, and 5, yeah? Okay, well, I'm going to do this the long way, and then we'll see why we have a short way in comparison. Remember, x to the power of 3, y to the power of 4 to the 5th power means we're going to multiply this times itself 5 different times. And as I begin to write this 5 different times, I realize that I wish I had picked a smaller number. Oh well. So we know how to multiply things if they have the same base. We're simply adding the powers together. So here I have 5 instances of x to a power. So I'm going to add all 5 of those exponents together. Okay, so that's going to be x to the power of 3 plus 3 plus 3 plus 3 plus 3. 3 plus 3 plus 3 plus 3 plus 3. Now, this that I'm writing is not usually the way we do it. I'm doing it the long way. But then we'll see why there's actually a much shorter way in just a moment. Here we have y to the power of 4 times y to the power of 4, y to the power of 4, y to the power of 4, y to the power of 4. Which, when you multiply things that have the same base, you add the powers together. Like that. Oh yeah, but that's 3 added together 5 times. 3 plus 3 plus 3 plus 3 plus 3. Can you just write that as x to the 3 times 5? And over here, that's 4 multiplied times itself. Added to itself 5 times. 4 plus 4 plus 4 plus 4 plus 4. Isn't that just 4 times 5? Oh, but notice, 3 times 5. There's that 3 and that 5 multiplied together. Here's 4 and 5. Here's that 4 and that 5 multiplied together. Here, our answer is x to the power 15, y to the power 20, and we get a slight variation on the power rule for exponents. This that I'm about to write is not different than this property that I have written up here. It's not different from this rule. However, it is a slight variation, which is helpful to remember. Note, if you have something like a, I'm already using b, so I'm going to use a different letter here. A to the power of m times b to the power of n, and you raise that whole thing to the power of, let's say, p. Well, then notice what happened. You had this first exponent times the big power, and then the second exponent times the big power. So that's going to be a to the power of m times p. These two multiply together. And then you're going to have b to the power of, and these two multiply together. Just like that. So for example, let's say I had x to the power 9, y to the power 6, whole thing raised to the power 4. Well, you could also think of that as x to the power 9 times 4. These multiply together. And y to the power 6 times 4. So notice that's much shorter than having to write out the whole thing and use other properties of exponents, because now we're simply multiplying 9 times 4, gives us x to the power 36, and y to the power of 6 times 4 would give us 24. Just like that. And that's our result. Okay. Fractions work a similar way. Because let's say I had x to the power 5 over x to the power, let me use a different letter here, y to the power 4, whole thing raised to the power 3. Now here I learned to use a smaller number, yeah? Alright, well that would be x to the power 5 over y to the power 4 times x to the power 5 over y to the power 4 times x to the power 5 over y to the power 4. After all, that's what it means to take x to the power 5 over y to the power 4 and raise that to the third power. But when you multiply that together, notice that's x to the 5th times x to the 5th times x to the 5th. When you multiply fractions, you just multiply across the top. So that's 5 plus 5 plus 5. Well, really, isn't that just x to the 5 times 3? When you multiply fractions, you just multiply across the bottom. Well, that's y to the power 4 plus another 4 plus another 4. Well, yeah, but isn't that 4 times 3? Well, yeah, 5 times 3 and 4 times 3. So here our answer is x to the power 15 over y to the power 12. And we get another note. Again, this isn't different from the power rule. We're still using the power rule. However, it is a slight variation that's used whenever you're dealing with rational expressions, whenever you're dealing with fractions. If you have something like a to the power of n over b to the power of n, the whole thing is raised to the power of, let's say, p. I'm going to use the same letter as I did before. That's just going to be a to the power of m times p over b to the power of n times p. This power simply distributes to the powers inside, just like that. So for example, if we had x to the power 9 over y to the power 8, and we raise the whole thing to the power 4, that would simply multiply these together. That's x to the power 9 times 4 over y to the power 8 times 4. This times this, and then the denominator, this times this. So in the end, our result would be x to the power 36 over y to the power 32. And if need be, you can always combine these properties. You can always combine these two. by saying, well, what if I have something that involves multiplication and division, and I'm raising all of that to a power? Well, that's fine. You can do that all together. For example, let's say we're going to simplify the following expression. X to the power 7, y to the power 12, over z to the power 8, and the whole thing is raised to the power 5. All right, well, here I'm allowed to raise the entire numerator to the power 5 and the whole denominator to the power 5. Okay, so if I raise the whole denominator to the power 5 using the property that I just saw, that's going to be z to the power 8 times 5. But notice that when I raise this numerator to a power 5, well, that's a product, which, given this note right here, that means I can simply apply that power 5 to each of those on their own. So this would be x to the power 7 times 5, and that'll be y to the power 12 times 5, like that. So this will give us x to the power 35. This will give us y to the power 60, 12 times 5, 60. And here's z to the power 40. Just like that. So let's go ahead and give this a try. Simplify the following expressions. Let's try x to the third, y to the fifth, and the whole thing raised to the 7th power. Go ahead and try x to the 5th over y squared to the 4th. And go ahead and try 2x squared y to the 4th over z to the power 6. The whole thing raised to the 3rd power. Go ahead and pause the video, give these a try, and once you are done, go ahead and unpause and we'll go through them together. Alright, so let's take a look. Here, this is going to be x to the power 3 to the power 7. And this will be y to the power 5th to the power 7. So whenever you raise something that has a power to another power, those powers get multiplied together. So this gives us x to the power 21 times y to the power 35. Okay. This one right here, that's going to be x to the power 5 to the power 4 over y to the power 2 to the power 4. Whenever you have a fraction, rational expression, and you raise that to a power, the numerator and the denominator get raised to that power. So this is now going to be x to the 5th to the 4th, which is x to the 20. And whenever you have something that has a power and you raise it to another power, the powers multiply together. Here, this will give us y to the power 2 times 4 is power 8. And now, here, we can go ahead and do the same thing for this one. Notice here we have just a regular number raised to a power. That doesn't require any of these rules. It's just a regular power. 2 to the 3rd power, well, that's 2 times 2 times 2, which is 8. If you have x squared to the 3rd power, well, that's going to be x to the power 6 when you multiply 2 times 3. And y to the power 4 to the power 3 will give us y to the power 12. Because again, whenever you have something that has a power and you raise that to another power, those powers multiply together. This right here is not the same as these. This is just a regular number, a regular constant. So 2 to the 3rd power, 2 times 2 times 2, that's 8. And then your denominator, z to the power 6 to the power 3, will give us z to the power 18. Note that you can combine these properties with any other properties of exponents that you may know, that you may have seen before. For example, let's say we have x to the power 5, y to the power 3, z, without any power. Now remember, without any power means power 1. And now that whole thing will be divided by, let's say 7, x, and again, without a power, that means power 1, 7x y to the 2nd, and then the whole thing will be squared. Okay, well, notice that in here, we can simplify even before we get to the squaring. After all, parentheses do go first, which means we should look in here before we look at anything outside. And in here, I notice a few things that I can simplify. For example, right here, these have the same base, which means I can simplify. Here, by dividing x to the power 5 by x to the power 1, that'll give us x to the power 5 minus 1. Or in other words, that'll be x to the power 4. These also have the same base, so you can subtract their powers as well. You can have y to the power 3 minus 2. Notice that z in the numerator, that doesn't combine with anything. There's nothing else that has that same base. That's the number 7. Likewise, that has nothing it can combine with. So those are going to stay right where they are. The z will stay as it was because nothing combines with it. And the 7 stays as it was because nothing combines with that. Now, this whole thing will be squared, which means we're going to end up with x to the power 4, y to the power 1, or we can just say y if we like, and then z over 7, and that whole thing is squared. So now, just like we see above, anything that's being squared can be applied one at a time to each of these terms in the numerator and in the denominator. All right, so let's take a look. That's going to be x to the power 4 to the power 2. That's going to be y to the power 2. That's going to be z to the power 2 over 7 to the power 2, because that applies to numbers as well. All right, so here, x to the power 4 to the power 2. When you have something that has a power and you raise that to another power, those powers multiply together. So we get x to the power of 8. Here, y gets squared. Okay, well, that's y squared. And so then here, z gets squared. Okay, so that's z squared. Over 7 squared. Remember, that means 7 times 7. And 7 times 7 is 49. So this is our result. X to the power 8, y to the power 2, z to the power 2 over 49. So go ahead and give this a try. Let's see here. Let's try 5x. Oh, let's see here. Let's do 5x to the power 3 times y. Now that whole thing will be raised to the 4th power. Now we're going to take x squared times y, and that whole thing will also be raised to the 4th power. And then we're going to divide all of that by 5xy, and that whole thing will be squared. Okay? So go ahead and give that a try. Expand this out and simplify using the power rule for exponents along with the other rules of exponents that we know about how we multiply and divide exponential expressions. Go ahead and pause the video, give that a try, and once you're done, you can unpause and we'll go through it together. All right, so let's take a look now. Here, we're going to go ahead and we're going to expand this part first. Now you say, well, can we combine this way or this way first? Well, remember the order of operations. Parentheses and exponents are going to go first, then we'll worry about multiplication and division. So we're going to go ahead and do the exponent first. So let's go ahead and use this exponent. This is going to be 5 to the power 4. Okay, well that's going to be 5 times 5 times 5 times 5. 5 times 5 is 25, times another 5 is 125, times another 5 is 625. X to the power 3 to the power 4, that'll give us x to the power 12. And then this y to the power 4 is, well, it's just y to the power 4. Now we're going to go ahead and handle these exponents as well. Remember, exponents all have to be done before any other multiplication or division. That's the order of operations, exponents before multiplying and dividing. If we have x to the power 2 to the power 4, that'll give us x to the power of 8. And again, y to the power of 4 is, well, it's just y to the power of 4. And then, so now, in the denominator, 5 squared, well, that's 5 times 5, that's 25. X is being squared, so x to the 2nd power. And y is being squared, again, y to the 2nd power. So now, we've taken care of our exponents. Now we look at multiplication, division. Here, let's go and combine everything in the numerator first, and then we can divide out. So up here, you have 625. You have x to the 12 times x to the 8. Remember, when you multiply two things that both have a power, you can go and add those two powers together. So x to the power 12 times x to the power 8 is x to the power 20, 12 plus 8. Now these are different from the x's, so you can't combine those together, but they are the same as each other. So even though you can't combine them with these x's, you can combine y to the power 4 times another y to the power 4, and again, you're going to add those powers together to give you y to the power of 8. Right, so now that is being divided by 25, x squared, y to the power 2, y squared. All right, so now this is just regular division. This doesn't have any exponent, it's just a regular number. 625 divided by 25, that's 25. All right? Okay, just take 625 and divide. This is not anything to do with exponents here. It's just regular old division. Just like that. Division. Now here, these are being divided because they have the same base, so you can subtract their powers. You have x to the power 20 divided by x to the power 2. That'll give you x to the power 18. 20 minus 2. And these two, they have the same base, so you can divide those by subtracting their powers as well. Over here, 20 minus 2 give us x to the power 18. Here, 8 minus 2 will give us y to the power of 6. And since nothing else can be simplified, since nothing else has any like base, none of these have any bases in common, that's as far as we can take it. So that is a fully simplified example. If you stopped anywhere before that, it wouldn't be wrong, it just wouldn't be complete. We keep going until every instance of x has been combined into 1. Every instance of y has been combined into 1. Every constant has come down into 1. You combine anything that can be combined with the common base, like this. So that's it for this material here. If anybody has any questions, comments, problems, please make a note of those and reach out. And I hope everyone has a nice day.